A very good morning. Welcome back. This is for part 2 of our today's lecture. Okay, I have given you a general introduction just now, big picture of what you're going to learn this semester. Okay, week 1 to week 14. Okay, for part 2 is what we call an introduction of vector dynamics. Okay, um, just give me a feedback whether you can see the slide.
Yes, we can see.
Yes, right. Okay, for vector dynamics, because in mechanical engineering, what we have is what we call engineering mechanics. Okay, so you are okay, we are in a mechanical engineering program. So what we have learned in engineering mechanics is you have what we call a rigid body. Okay, rigid body. In engineering mechanics, we have rigid body. Okay, rigid body. And then we have also this body is rigid. Okay, and then we have another type of body, which is the body which can deform. We call it deformable body. Okay, and then another type is fluids. Okay, fluids. It's where we have fluid mechanics and fluid dynamics. And then we have here we are under this section. Okay, a rigid body. So the coverage or the scope of what we cover here is related to rigid body. Rigid body. We have static. We learn static, which is in MEC412, and now is Uto. Okay. So static, something that is not moving, and then dynamic, we are talking about, the body in motion. Okay. Motion from one point to another point, one place to another place. Okay. Okay. So dynamic concerns in motion. We talk about something that is in motion. Okay, just now I mentioned about kinematics and kinetics. Okay, so you should be able to differentiate between what's the difference between the kinematics and kinetics. Okay, the blue in color and red in color, you can see there, right? So when we talk about kinematics, okay, basically kinematic is a study of motion. The keyword is motion. Okay, study of motion without reference to forces. Okay, okay. So we are not having any forces here. We talk about study of motion without reference to forces, which cause the motion. So for kinematic, you have R here, position vector, you have the velocity, you have acceleration. And then you also have as a function of time. Okay, because here R is a position vector. Here we have the velocity vector, which is a vector. Has a direction, and then you also have here the acceleration. Okay, so this is for kinetics. And how about kinetics? Okay, so when you say kinetics, you have force. Okay, what will happen when the force apply on the body? Okay, action of the force. Okay, and then what will happen of that force on the bodies, and what will be the resulting force? Okay, so it will be governed. When you say kinetic, it will be governed by different type of law. Okay, so in this case, it will govern by different type of property. First property is Newton's second law. So we have here Newton's second law. Still remember summation of force. Okay, this is how we write. Because in this class, we are trying to have same textbook, same way of writing the notation. Look how I write. We have a summation of force. Okay, so this is vector. So I underscore here. Okay, means the vector. Okay, equal to mass times acceleration. Okay, F equal to mg. Right? Okay, and then we express in the coordinate system, different type of coordinate system. Okay, so we have different type of coordinate system. We have um, um, rectilinear, we have curvilinear. Okay, we use different coordinate system. Okay, for example, polar coordinate system, cylindrical coordinate system. Okay, all of that you have learned mathematics. So we apply mathematics in engineering. Okay, so look at this statement here. Dynamic. So what is dynamics? Dynamics is a science that describes and predicts the condition of rest or motion of the bodies under the action of forces. Okay, so it is a science that describe and do the prediction, the condition of a rest or motion of the body under the action of forces. Okay, this is the one of the definition of dynamics. Okay, I have mentioned this just now. Okay, we go a bit detail on kinematics. Okay, we have defined this. The kinematics is the study of motion without reference to forces. Okay, we have here position. So please familiarize with yourself with this terminology. We have here position, and then we have displacement, we have velocity, and acceleration. Okay, so for the first one, let's say we have this particle. Okay, this particle, the red in color, is located here. Okay, and then this particle is moving to your right. Okay, okay, at t second. Okay, now it is at position 2. This is position 1 or position 0. I call this position 0. Then this is position 1 at this time. Okay, and this particle has the velocity of v. Okay, velocity of v, v. Okay, all right. So from 0, p0 to p1, so we have what we call the position 0 to position 1. So it has the displace from p0 to p1. So p0, p1 minus p0. So we have distance, distance s. Okay, distance s. Okay, and then we have another position. This is datum. I call this datum. Okay, datum is the place where we start. Okay, 0, this position, to P1 or P2. So you have another one here from this datum P0 to P2. So you have here, um, so you have S plus ds. ds means the small increment of the displacement. Then S plus 0.1, 0.2, 0.3 until it reaches P2. Okay, all right. So we have here the first layer here. I talk about only on S, which is displacement and relate with position. These are the first layer. Okay, talk about position and displacement. After that, we talk about velocity. And the upper part, this upper part is time. T0 and then this particle move from P0 to P1. So we have T0 and then time. And then from P1 to P2, which is from P0 to P2, you have T plus dt, which is differential of time. Okay, differential of time. All right. So first layer, position displacement, and then second one we talk about time, T0 and T, and then T plus dt. And last one I'm talking about the velocity. Okay. Now we talk about the velocity here. We have the velocity. Okay, the velocity here, which is here. This is velocity, velocity. And then from P1 to P2. So P2, we have another one, V plus dV. Differential in V, small changes in V. And it's add up, okay? Add up together. So now the third layer is we are dealing with the velocity, okay? All right. This is the explanation of the figure and relate with the motion, okay? The motion. Next one, we proceed with the equation. How to relate of what I have mentioned just now with equation. This is differentiation. Okay, we differentiate. Kita bezakan v velocity equal to s dot. What is s dot? S dot we differentiate s with respect to time. Okay, so ds dt is s dot. Yeah, s dot. That is the velocity. How about the acceleration? Now we want to find the acceleration. Okay, so for acceleration, we know that v equal to v dot. Okay, what is v dot? We differentiate v with respect to time. And then to relate with displacement, we going to have ds square dt square. Okay, or we can write, v times dv ds. Okay, if you want to relate velocity with s. Okay, can write in terms of time dv dt, or can relate with displacement, okay, by using this equation. Okay, next one, we elaborate just now about kinematics. Now we move to kinetics. I give you a few minutes, a few seconds to try to understand and figure out what kind of forces applied to this particle, okay, and then try to relate with Newton's second law. So I'll give you a few seconds, about 30 seconds or 1 minute to figure this out. Okay, again, I have mentioned just now, kinetics is the study or motion of the body with reference to forces. Okay, reference to forces. Okay, which cause the motion. Okay, so if you look at this particle, same datum, we have here datum start with 0 at t equals 0. You move to your right, okay, from 0 to p1, position 1, with a distance of s, okay. And then this particle, okay, this particles, okay, this particle, okay, this particle, you can see, I draw here along the line, okay. Um, it's move, it move, it move. This is, let's say, this is the ground. So the direction of this particle is moving is to your right, right, to your right, this direction. Then so we have here F force. This is okay. You say you have the value of M, and then you have normal force. Okay, so the direction of force to the right, and then you're going to have another force which is to oppose the motion, which is frictional force. Okay, frictional force. So we have here normal force, frictional force. We have here the body weight. Okay, the body weight. And then this is for summation of force, and then another one you will have the direction. This is what acceleration. Okay, kinetic diagram. So all of this force we put it under summation of force. Summation of force, which is so you decide the datum, which is to the right, is positive. Okay, and then you also have this is summation of force in x and y direction. So you also have in y direction summation of force in x and y direction. Okay, summation of force is in x, it can be in y direction. So you say going up is positive. Okay, so all of this is related to summation of force, and then you're going to have mass time acceleration. Okay, so we relate the total resultant force to acceleration. Okay, with mass. Okay, mass and time. All right. Okay, this is the detailed content. The detailed content. I have elaborate just now. Just to quickly to recap. So for this week, we cover, before we proceed to cover this, we do a review, review of a vector. Okay, this is what we're going to do. Okay, these are basic terminology. Basic terminology where rigid body, particle, static, dynamic, length, area, volume, force, mass, and weight. And these are the basic terminology that you're going to see again and again in this class. Next one is about the unit. I mentioned a few times just now about the unit. These are the four fundamental quantities: mass, length, time, and force. Okay? These are the fundamental. Okay, and then for dynamic, these are the fundamental. We have mass, we have length, we have time, we have force. So unit for mass is kilogram if you are using SI. Okay, unit of length is in meter. Okay, and then the unit of time is in second, and unit of force is in meter. Okay, this is for SI. Okay, when you also need to familiarize yourself with other system, a British system. or US customary system. Okay. Even in thermodynamic that you learn, especially in design econ, HVAC, most of the handbook they are using British system. Okay, well, how many watts will be the horsepower? Horsepower, BTU per hour. So you need to know how to convert. Okay, to convert the value. Okay, all right. So in for British system, they use pound m, or slugs. This is for the mass. Then for the length, they use feet. Okay, and then for time same, this in second. And for the force, this is pound. Okay, this is pound. Sometimes they use this notation. Hashtag in US customary or British system means pound. Okay, or pound F, pound force. Small force subscript is pound force. Okay. All right. Any questions so far before I proceed to talk about the type of coordinate system? Any feedback so far? So far, so good. Are you okay? Or are you not? Are you with me or not with me?
Yes,
So far, okay.
So far, okay.
Nurul Huda, are you okay? Are you following me?
Yes, Prof.
Sure.
Yes.
Arifah, are you okay?
Yes, sir.
Sure. Okay. Whether we know okay or not okay, we're going to have short quiz and see the understanding the okay or not okay. All right. Alhamdulillah. A sip of coffee and then I continue. Okay, types of coordinate system. We proceed with this one. Okay. As I mentioned just now, we're going to have different type of coordinate system. Okay. In dynamic, we don't have many type of coordinate system. Okay, that we're going to use here. Only mostly we use this type of coordinate system. Like we have rectangular, we have cylindrical, and normal tangential. Okay. Very rare we use spherical coordinate system, but you have learned all of it in mathematics. Okay. Look at this figure. Okay. This is different type of coordinate system. Okay. We start with the first one. Okay. First one. Okay. For the first one, I'm telling you here, this P is a particle. Okay, particle. This particle is moving along this path. Okay, it moves along this path. Okay, along this path. Okay, that's why you can see the arrow. This is the path dia punya laluan lah. Okay, okay, point A, point B, point B. Into any point lah along this path. Okay. All right. And then what I'm going to, when we want to set up the coordinate system, we start having a rectangular coordinate system, starting with X, Y, and Z. Okay. X, Y, and Z. Okay. X, Y, and Z. This is a rectangular coordinate system. First one. This one. X, Y, and Z. Okay. So positive lah. This direction is positive. If going back is negative lah. Okay. Here also Y is positive Y. Is positive. Okay. Positive Z. Positive X. This is positive Y. Okay. Going to this direction. All right. when we locate particle here, okay, what we are going to do here, we can draw the plane here, okay, like a slice of cake, a plane, like we cut the cake and go beli cake from secret recipe, you cut into slice. Imagine you cut only the plane. Look at the plane or sectioning. You learn in drawing also. You learn about sectioning. You cut. Okay. So we have this is what we call the cross section of it. Okay. The plane. This is the plane. Okay. Plane for that. Okay. So the blue in color. So when you have here this particle located at here, okay, so we start having here a datum, okay. This datum from 0 to this position, this is what we call R. This is position vector, okay, position vector, right, position vector. So we start with that one first, okay. Okay, I want to look at the normal and tangential coordinate system. Okay, let me erase this one. Mana dia punya? Okay, ada pemadam. No eraser. They have eraser. Okay. Alright. We have this plane, this path. Okay. When you have the path, always in mind, you remember tangent, normal and tangential coordinate. We have what we call path variable. Okay. So we have any path. So this particle here, it move along. Move along. So you will have normal and tangential. So that's why they call path variable. So for here, the tangential is here. Tangent. Tangent to the path. Tangent. And then normal is perpendicular to this tangent. Same thing here. Same thing here. At A. So this is tangent to the path. And then normal is perpendicular. Okay. How about this one? Where is tangent? How about this point? Let's say this is point B. What is the tangent direction? Particle move along this. Where will be linear? This direction or this direction? To the right or to the left? Or here? Tangent.
To the right.
The right, Sure, to the right. So perpendicular to the path, okay, and then normal, 90%. Okay, normal, tangential. So it move like that. Okay. So tangential and normal point will be changing along the path. Okay. This is what I would like to highlight when talk about normal and coordinate system. So in this case, you have tangential coordinate is perpendicular here to the path, and then you have normal. Okay, normal there, pointed the center of rotation. Okay, this is what we call radius of curvature. Some book they call radius of curvature. Okay, so this is normal and tangential. So this concept is clear. And then what you have here, another one, I think, normal and tangential. Okay, we talk about cylindrical coordinate system. Okay, so cylindrical and coordinate system, watch out here. It involve R, remember, R. Now I'm talking about this one, cylindrical coordinate. Okay, so we have R, small r, this is R. I'm talking about this R. Okay, this R from here to here. And then what else? Theta. Where is theta? Bayang, you have a drone, okay, watching from up. drone view, look at down, or eagle view. We talk about eagle view, not drone view lah. Okay, from top you can see this data. Okay, this R and this data. From this is your eye, your eye looking down. You can see this is the data, value of data. Okay, theta, and this is R. So cylindrical coordinate, you will have R, this is R, I'm talking about this R, and I'm talking about this theta, and then you talk about the height of it. Okay, from here to here. Okay, which is the distance of Z. Okay, so you have R, theta, Z. That one is for R, theta, and Z. Any one of you can give me one application of cylindrical coordinate system? Can you give me the example? Any one of you? The application of it, example of it.
Robotic arm.
Robotic arm. Okay. Any other example? Any other example? Have you been to playground? The kid they play going down. Right. Any other example?
Roller coaster, sir.
Roller coaster. Okay. Any other example? What will do when you want to change your tire? What equipment or device do you use?
Spring.
Jack, right? Jack. So you want to jack your car to change the tire?
Spring.
Spring. Helical spring. Okay. So those are the example of different type of coordinate system. Okay. Now allow me to highlight also this important reference axis. Okay. So because we're going to go through this again and again. Okay. We have here what we call absolute motion analysis and relative motion analysis. Okay. So coordinates can be measured from fixed reference axis. Okay, this is the terminology. Fixed reference axis or global reference axis. Okay, so this is absolute. And from moving reference axis or local reference axis, this is what we call relative motion analysis. So there are two different things. Okay, I'm going to go into detail of it later. So coordinate system, we have absolute motion analysis, and then we have relative motion analysis. Okay. These are possible coordinate system, okay, of the big picture, where this roller coaster, we treat it as particles or rigid body. It's a big picture. So dynamic problem, we didn't tackle it, at certain part only, because some problem it will come lumped together. It will be a combination of different concept to be applied together, okay, in daily life. So I think many of you have an experience to ride a roller coaster. Okay, we have few places around, whether in this country or in our neighboring country. Okay, we went there. You have tried roller coaster, but we want to relate your experiences, okay, by having a possible coordinate system in dynamic. So we have a roller coaster here. is moving from here, okay, point A, okay, this is the term I named this is 0 here, so start from point A, it move from A to B, okay, from point A to B, and then go to point C, and then start to D, and then E, F, and then it's going around, okay, one loop, go to H, I, and J, okay. So you can see different coordinate system that been used here from here to here. Okay, this is linear, and then start to have what we call a curvilinear motion here. Okay, curvilinear motion. We have here D, point D. This is radius of curvature, normal and tangential. Okay, tangential plus tangential direction. This is normal direction. Okay, all right. And then if you look it from here, okay, this is the viewer looking from E, and then you have angle theta. Then from here to here, you have position vector R. Okay, and then what you have here in terms of this cylindrical coordinate system, you have unit radial and you have unit radial. This is what you call unit radial plus, and then you have what you call unit transverse. Okay, unit transverse, this direction, and then go back again. We have here post ing, which is positive x and positive y. Okay, this is an example of roller coaster. Okay, so we can apply different type of coordinate system. Okay, different type of coordinate system. Okay, what is the time? 11:36. All right. We finished that one. This is a fundamental concept. Okay, fundamental concept. And then we have here the fundamental concept revisit. These are the 6 fundamental principles. Okay. If you recall vector addition, this is how to add up the vector, okay, using parallelogram law, okay, vector addition. And then I would like to highlight also here is Newton's second law, we have mentioned just now. And then you have another one is Newton's law of gravitation, okay, and Newton's third law, Newton's first law, okay, all of these you have went through. So all of these will be used in our dynamic topic later. Okay, I go one by one. Okay, quickly on the fundamental principle. First one is parallelogram law, which is vector addition of forces. Okay. Oh, okay. I think this one you can go through on your own. We straight go to vector. Where is vector? Okay, now this. This one. Okay. Okay. Straight away go to vector. Okay, vector. Can you see the slide of the topic of review of vector?
Yes.
Okay. Okay, this one. We have another 20 minutes. Okay. For this 20 minutes, I would like to review a few vector algebra and calculus. Okay. So I hope when you go home today, you can try to refresh and should be able to refresh your knowledge in vector algebra and calculus. So as we know, vector is a quantity. Okay, quantity. We have the magnitude and direction. This is vector. When we say magnitude, mean it has a distance. Okay, what will be the distance or the magnitude of it? And then it has a direction. Direction, we have this theta from data measured from 0 to theta. Okay, so that's what we call vector. So vector, it has number one magnitude and it has the direction. Okay, so if the quantity has a magnitude A, 5 Newton, okay, in the direction of 45 degrees. So we can represent this as the following. Vector A, we have the magnitude and then theta. Okay, vector A equal to magnitude and which direction. Okay, so if the quantity has magnitude 5 Newton, so I replace this with 5 Newton. This is 5 Newton. And then direction of 45 degrees. Okay, 45 degrees from where? 45 degrees from this 0, 45 degrees. Okay, from the term counterclockwise. Okay, okay, this is how we write. So A, vector A equal to magnitude multiplied by direction. Okay, which is 45 degrees. Okay, this is how to write. Done this one. And then I mentioned here vector obeys parallelogram law of addition. Yes. How it obeys? We'll take a look. Okay. Look at here. We have vector component, the two component. We have this vector V. So how to go from here to here? Okay. From 0 to here. So it will go this way. Q plus R, right? Q plus R. So V equal to vector R plus Q, okay, which is Q plus R, okay, this dotted line, or R plus Q, okay, nampak yang ni tail, this is head, I call this tail, this is head, okay, this is head, this is tail, okay, so this is tail head, so Q plus R, or R plus Q. Okay, this is what we call component. How about this one? V equal to this V. So use a parallelogram. Okay, so to go to here, we have we can add S V equal to S plus T. Okay, or can see V equal to T plus S. Okay, so at the head, at the tail, you can see this is tail, this is head. Okay, so again, this is tail, this is head. So this is head, this is tail, this is head. Okay, all right. This is how we represent the component. So for figure A, we have done that one. Figure B, we have done, and then we move to another one, which is what we call mutually perpendicular to each other here. So if you want to write the vector, yeah, this vector V, we can write in terms of V in X direction component, V X component and Y component. So I can write here Vx and then I can write here Vy. Therefore, V equal to vector X plus vector Y. Okay, we have this type of coordinate system. Okay, And then another thing that you need to recall is a unit vector. Okay, still remember unit vector. You have x, y, and z. X, y, and z. Okay, so unit vector I. Okay, this is j. Okay, and this is k. Okay, so unit vector. So if you want to write the velocity, okay, velocity of vx or v, okay, you can write vx, okay, unit vector plus vy j. Okay, so you can write in terms of unit vector. The velocity can be written in terms of unit vector as well. Okay, okay, for this one, the solution of planar 2D, you're using Cartesian. Okay, Cartesian coordinate system. Okay, you can resolve into x and y component. This one. So start from today, you do not confuse to interchange between sine or cosine. So make sure you really understand this. Don't interchange between sine and cosine. So we have here Vx. Okay, so put this 5 star. This is very important. People they tend to interchange, confuse sine and cosine. Yeah. So we have here the Cartesian coordinate system. You can resolve into x and y. X and y. So you have I mentioned just now, this is Vx, Vy. Okay, so for this one, you can from here to here, this dotted line. So this is Vx. Okay, Vx equal to V cosine theta. Okay, and then Vy, this one, this is Vy equal to V sine theta. Okay, put it 5 star here. Do not make a mistake. And then the magnitude and the direction of it. Magnitude of the velocity you can get as the following. We square root of both. Square root of both. Vx square plus Vy square. Okay, and then in order for us to get the value of theta, we have tangent theta here. Tangent theta of Vy divided by Vx, and then you take the inverse tangent of it. Okay, inverse tangent of Vy and Vx, so you can get the value of theta. Okay. Okay, this is for 3D. It's going to be the same thing. Okay, you learned all of this in static before. Okay, how to project this one. Okay, from 3D, can get the magnitude of the velocity, and then you what we call a direction of cosine. You have learned this one in static before. So cos theta y, cos theta x, and cos theta z, you must divide by v, which is the magnitude of v, and then from there you can get the direction of cosine for x, y, and z. Okay, and then this how to relate with unit vector. Okay, this is direction of cosine. Okay, direction of cosine. Okay, this is how to define a unit vector. Okay, we have 2 points here, point P, x1, y1, z1, and then Q, x2, y2, z2. And then we have the unit vector here. How to get the unit vector here? You introduce value of r. Okay, we have here r equal to ru. Okay, ru. Okay, r is square root of x square y square plus z square. Okay, so how to get those? Using this formula, unit vector equal to pq, okay, divided by magnitude of pq. Okay, so how to get pq? So kita tolak lah, minus this one, x2 minus x1, y2 minus y1, and then z2 minus z1, and then divide by square root of those. So you get the unit vector of it. This is what you have learned in static before, how to define a unit vector. Okay, this is an example, can go through on your own. Okay, when discussing tutorial class later. Okay, another example. Okay. Another important thing also I would like you to review is to review basic concept of algebra. Okay, subtraction by having this A and B. Okay, and then addition and subtraction. So to add and to subtract is straightforward. This is we have an example. A, we have the value here. Okay, I, J, and K. And B is minus 2I plus 4J plus 3K. So if I want to add A plus B, so 3 plus 2 minus 2, 3 minus 2, 2 plus 4, okay, 6. And then minus 5 plus 3, okay, minus 5 plus. So you get the answer. Addition, very straightforward. And minus also would be the same, okay. How about multiplication? This one need to put a lot of attention. Okay, this is what we call dot product. Going to use a dot product a lot later. That's why I want you to go through all of this. This is the concept of it. Okay, and then this is how they do the dot product for this vector. They have 1, 3, minus 5, 4, minus 2, minus 1. So you do dot product, you write in terms of a vector here, and then 1 times 4 plus 3 times minus 2 plus minus 5 times minus 1. So you have 1 times 4, 4, 3 minus 2 minus 6 plus 5, so you get 3. Okay, this is dot product. So dot product is not a vector. Okay, it's not a vector, it's a quantity. Yeah? It's a value. Okay, so same thing here, you have two vectors A and B, and then you do dot product. So you do dot product A dot B. Okay, A dot B. Same thing, 3 times minus 2 plus 2 times 4, and then minus 5 times 3. So you get minus 17. Okay, so by definition, A dot B, this one, A dot B is basically A times B cosine theta. Okay, so dot product is basically A dot B equal to A times B cosine theta. This is how it look like. Okay, okay, this is dot product. Now we talk about cross product. Okay, cross product. So okay, some book they use vector A times vector B. So we are not going to use this. So start from today, for cross product, because I don't want you to confuse with X. So throughout our UITM student, we're going to, for this class, we're going to use cross product as this one. Okay, cross. So vector A cross vector B. Okay, this is what we're going to use. So the formula A cross B is basically A magnitude of A times magnitude of B, and then sine. Okay, sine N. Okay, so V equal to A cross B. Okay, see the plane? The plane contain of these two vectors. Okay, so you have unit the value of n perpendicular to this blue plane. Okay, we have that theta. Okay, so A cross B equal to AB sine A. Okay, so remember, cross product is A cross B. Okay, and this is this figure how it's look like. Okay, all right. So these are the example. Okay, still remember this one. We try to draw I, J, K. Okay, so I cross J, you get K. Okay, okay. J cross K, you get I. Okay, so K cross I, K cross I, you get J. Okay. So I cross J, you get K. Okay. This is how we do the multiplications. To remember all of this. Yeah. So I cross J, you get K. This is how it looked like by using the formula earlier. Okay. I cross J, you get K. And then J cross I, J cross K, J cross K, you get I. And K cross I, you get J. Okay. How about if I cross I cross I, because of sign 0, 0. So I cross I, J cross J, K cross K, all of them will be 0. So therefore, you're going to get this one. Okay. And this is an example how to use the value. If my way, what I'm going to do, I'm going to put like this, I, J, and K. I, J, and K, and put the value 3, 2, and minus 5, and then this is minus 2, 4, and 3. So to solve I, you solve J, and then you're going to solve K. Okay. So this one you can get using Cramer's rule. Okay. Cramer's rule. It's much easier. Okay. Okay. How about this one? This is very important. I want you to put 5-star here. How we can use vector calculus? Involving differentiation is given. Okay. So macam ni lah. You differentiate addition and subtraction. You differentiate dot product, and you differentiate cross product. Yeah, this is how it will look like. So for this one, we look at the first one. You differentiate one by one. Start with A. You differentiate A. Vector A, you get A dot, and then you differentiate B, you get B dot. Okay. Okay. This is plus minus. Okay. Same thing with dot product. Differentiate. You differentiate this one done. I think this one clear. Number 2, you differentiate this one first, and then this one you make it constant. Okay. And then second part, you allow the first part to be constant, and then you differentiate the second one, which is B. So you differentiate A, you get A dot here, and then times B. And then second one, A become constant, so you differentiate B, you get B dot. Okay. Same thing with cross product, same thing. Same technique applies. You allow this part to be constant, okay, for the first part, and then the second part, A become constant, you differentiate B. So you get A dot cross B plus, this is constant, A cross B dot. Okay, this is how we differentiate. Okay, same thing with the last one. If A equal to magnitude A times unit vector, so you differentiate, you do the first part. Okay, first part A dot, and then U constant, and then second part you allow A to be constant and you differentiate unit vector. Okay, this is how we do differentiation. Okay. All right, I think that's all for today. I'll see you this Wednesday.
Okay,
Thank you.
can okay, yes, Professor.